Welcome to Gardin, the leading platform for real-time crop insight and precision growing. Gardin sensors measure the plants to help you steer the climate based on their needs. In this video, I'll walk through the Gardin app and explain the core parameters that help you make smarter growing decisions, from light use efficiency to crop health. Clicking the link in your email will take you to the Gardin Pulse dashboard. Here we have the grower Demo Grow, which is data from the 2024 Autonomous Greenhouse Challenge, in which we participated growing dwarf tomatoes. So when we click on Tomato Greenhouse, the lines views come up. Here we can see several plant factors, including health, efficiency, and productivity. Health is a percentage score for how ready the plant is to grow, indicated by the leaf. Efficiency is the percentage of light usefully used for photosynthesis. Balance indicates the assimilate balance in the crop, and productivity is the daily electron transport, which estimates plant assimilation, and it's shown for the past 7 days. This allows us to easily monitor and compare crop performance between different sections of the greenhouse without even stepping inside. As you can see, the icons have different numbers underneath, which tell you how well they're doing based on Gardin's metrics. In this case, most things look fine, but the balance seems to be a bit too high and the health is lower than we would ideally want. Let's have a closer look at the data. So when you click on a line, you're taken to the Details View page, with the hourly efficiency chart shown by default. The different colours represent each area of the greenhouse where sensors have been installed. Demo Grow has 3 sensors, so 3 different colours. Now we can visualize exactly how plants are doing in different metrics, comparing different factors side by side. Right now, I'm in the efficiency section, highlighted in a brighter white at the top. I can see a graph of the light use efficiency over the past 3 days, indicated by the dates at the top. I can flick through each metric to easily see how each aspect of the plant's growth is doing. It's easy to change the time frames of the graphs you're viewing. You can go as far back as several months or right up to the present moment. Efficiency shows how well your plant is converting light into usable energy for growth. The dark period is the night measurement when the plant is most relaxed. The optimum level is a horizontal line, which shows the point up to which about 1% more light gives 1% more yield. Beyond this point, you get diminishing returns. Go too low, below the minimum line, and you risk permanent damage to the photosystem and long-term growth. Increasing the light intensity between the efficiency and minimum is the fastest way to growth, but can be more expensive if using LEDs. If I want to compare the lines, I can easily click on one and highlight its efficiency over the last 3 days, which has nicely been tracking the optimal line, so the light intensity looks good. When you hover over the graph, you'll see that every line consists of dots. These dots represent averages of at least 10 measurements. A measurement takes 30 seconds, so 10 in 5 minutes and 30 in 15 minutes. Let's look at other metrics to gauge how the plant is doing. Balance measures the plant's light source-to-sink ratio. In other words, it shows whether the plant can satisfy the demand for assimilates by the fruits or flowers. Your target is to keep the light balance within +25 and -25. In this graph, there's an upwards trend, which showed a good balance during fruit growth, but the plant was saturated during the ripening phase of the tomatoes, implying that we could have lowered the amount of supplemental LED light. I can also see that there was a peak recently, so I'm going to investigate that. So if I hover over a particular peak, I can see the exact day of the peak and the values of all three lines. All lines were outside of our range. For example, line 1, the green line, had a value of 40.6. Over the same time, we can see the health of the plant has dropped, which was likely caused by this assimilant imbalance. Health is a good measure of how resilient the crop is to stress. Gardin's growing partners average 80% and aiming to exceed that. If it drops below 70%, you should take action. The plant is struggling to sustain itself and yields will likely suffer, through fruit or flower abortion. The experiences of the plant during the day influence the recovery each night. Therefore, it is interesting to look at the trends to see if we can learn what increases and decreases the recovery. Next, PPFD. This is the same as PAR, which stands for photosynthetically active radiation. It tells you how much usable light is actually reaching the leaves. Gardin shows you the optimum and maximum levels, corresponding to lines on the efficiency graphs, so you can fine-tune your lighting strategy to boost efficiency without causing damage. Next, let's take a look at productivity. When we multiply the amount of light reaching the plants by the efficiency of their conversion of light into energy, we get the total amount of produced energy, which we call productivity. This energy can then be used to assimilate CO2 into sugar. We can view this as actual production, showing us the production per 5 minutes, or as cumulative production throughout the day. Similar to how the sum of light during the day is called the DLI, the daily light integral, we call the sum of production the DPI, the daily photosynthesis integral. Interestingly here, despite all the lines receiving the same amount of light, they achieve different levels of production, and this is due to differences in which the plants were able to process that light into chemical energy, shown by the health and efficiency. For this reason, it's important to measure several areas of your farm. Gardin recommends at least 2 per hectare. Actual productivity is the average electron transport rate which occurred in a 5-minute window. DPI can be used to align your 24-hour temperature with actual plant activity and feed it into your yield forecast as an improvement from DLI. If I wanted to look at just one line, I can easily do that by clicking on the area button and deselecting the other lines. Moving on to DPI versus DLI. As we can see here, each line has several circles which represent different days and different ratios, so we can compare how often each line is hitting the ratio. The trend line for line 3 shows how DPI increases with DLI. A flatter slope might indicate stress, light saturation, or inefficiencies. Your goal is to maximize DPI without overloading the plant with light. Use this chart to spot underperforming zones and adjust light or climate conditions accordingly. Ultimately, this view helps you balance cost and performance, making sure your energy inputs are delivering maximum growth return. By tracking and managing these metrics through environmental optimization, Gardin gives you the tools to make better decisions, reduce waste, and grow more sustainably. It's easy to get started with sensors, available on a monthly subscription. Just getting to contact through our website today.